Good day, everyone. So I will be discussing a study titled Geophysical Prospecting of the Coptic Monastery of Abydos using GPR and Magnetic Techniques, a case study in Abydos, Sohag, Egypt. And this research explores the integration of geophysical methods to uncover the hidden archaeological features beneath the marketplace of Abydos. And for the table of contents, the paper was divided into these 8 parts as shown. But first, let's discuss the introduction. So the Abydos, Sohag, Egypt, which is originally called the Abdu, and is one of Egypt's oldest and most significant archaeological and religious sites. And it also served as a key burial grounds for early pharaohs and top officials, notably Seti I and Ramses II, and it was deeply tied to the cult of Osiris. And the research paper was centered on this place with the primary objectives of searching the lost Coptic monastery of Abydos, which ancient records mention its existence, but its exact location remains a mystery and believed to be buried somewhere under the active modern marketplace of Al-Abara village, and as well as to detect other potential archaeological features. And to achieve this, the researchers employed a combination of ground magnetic and GPR survey to detect subsurface anomalies to indicate of archaeological remains. For the ground magnetic survey, it is used to detect magnetic anomalies due to differences in magnetization and magnetic susceptibility of buried materials, and it is an effective way in identifying features like mud brick structures due to their magnetic contrast with surrounding soil. While for the ground-penetrating radar, it provides high-resolution image of subsurface features and determines their depth, size, and shape, and its success depends on soil type, moisture, mineral content, and vegetation. And this figure 1 and 2 is the location map and description of the study area. Now moving forward to the archaeological background, for the historical importance of Abydos, it was a major religious center in ancient Egypt tied to the cult of Osiris, and it served as a burial site for both royal and non-royal individuals, meaning to say that Abydos is a central site in ancient Egyptian culture, specifically significant during the Pharaonic and Coptic periods. And lastly, the Apamosis and Monastery, wherein Apamosis, a Coptic patriarch born in 470 CE, likely founded the Coptic monastery at South Abydos, and the actual remains of Apamosis Monastery have not yet been located, and this site may hold a clues to both Coptic and earlier Pharaonic history, as well as modern archaeology aims to locate the remnants of this monastery. Next to this is the geological setting, wherein the Sohag region is composed entirely of sedimentary rock units, and these formations range in age from lower Eocene to recent. And the area has undergone multiple tectonic movements, shaping its geological structures. And those structures include normal faults, strike-slip faults, and folds, wherein they are most likely linked to tensional forces. And this table shows the major geological formations in Sohag Governorate include study sites. Then for the materials and method used, there are 2 methods, and the first one is the magnetic method survey using 2 Geometrics 857 proton precision magnetometers. One is for the base and one is for the field unit, having a precision of 0.5 nanotesla, resolution of 0.1 nanotesla, and it covers a study area of 3 blocks composed of A, B, C block, with a total of 987 stations. The other one is the ground penetrating radar method using an instrument of GSSI SIR 4000 with 200 MHz monostatic antenna to provide good vertical resolution and accurate depth estimation of the buried objects. Now let's move forward to the result and discussion. For the magnetic data interpretation, it was used to identify both shallow and deep subsurface anomalies, and the TMI anomaly map and its derivatives were interpreted qualitatively and quantitatively. First, for the total magnetic field intensity or TMI map, wherein it revealed the rectangular and square anomalies ranging from 5 to 7 meters wide scattered across the sites. And the Black Sea displayed the highest magnetic values and were insignificantly greater than blocks A and B. The high readings in Black Sea are most likely linked to marketplace activity, including the presence of iron debris, granitic stones, and burned materials. Next is for the Butterworth high-pass residual map, wherein it is used to isolate the shallow sources, applying a Butterworth high-pass filter. And these highlighted anomalies likely associated with mud bricks tombs. Interestingly, the magnetic contrast indicated that the interiors of these anomalies had lower magnetic values, wherein it is possibly due to displacement with low magnetic material like sand over time. And for the first vertical derivative and analytical signal maps, wherein the first vertical derivative map allowed us to detect boundaries between high and low magnetization areas. Meanwhile, the analytical signal map shows a graph gradient peaks and revealed more detailed anomaly shapes, particularly in Black A and C. And these results further supported the presence of buried rectangular structures. For the tilt angle derivative map, it is used to define fault and contact zones, showing where magnetic contrast is the highest. For the source parameter imaging, wherein it is used to estimate depths ranging from 0.7 to 4.8 meters, and it is consistent with archaeological layer in the area. And the 3D Euler deconvolution, wherein it is used to confirm the depth with different structural indices to easily classify the geometry of buried bodies. And most notably is the depth range match the SPI results, strengthening our confidence in the anomalies being of archaeological origin. Going back to the total magnetic field intensity map, wherein the figure here shows the relief maps of, the first figure is the total magnetic intensity, next is the high pass filter, then the first vertical derivatives filter, the analytical signal filter, the tilt derivative, the source parameters imaging techniques, and lastly, the Euler deconvolution solution with structural index and Euler deconvolution solution with SI is equal to 2. And the black circles here represent the magnetic anomalies that were confirmed by the GPR approach and maybe artifacts. Next one is for the ground penetrating interpretation, wherein over 500 radargrams across 12 blocks were analyzed. In three areas like Block A and 1 and Block C3, multiple hyperbolas were detected, including buried objects of varying shapes and amplitudes as shown in the table. And this table, it shows the summarized parameters of the detected anomalous features at the study area. For the next part, which is the integration of the geophysical data, wherein it only discussed the magnetic and the ground penetrating radar methods that were both applied to increase reliability in detecting subsurface anomalies. And these anomalies identified by both methods were considered likely archaeological features, and the confirmed targets were located at depths between 0.7 meter and 3 meters. So in total, Six shallow targets were identified, with anomaly 6 being the largest and is likely representing the buried monastery of Apa Moses. Here's to conclude everything about the research. For the location, which is the Abydos marketplace, Sohag, Egypt, wherein it is a historically rich archaeological site, with the main objective of exploring the buried Coptic monastery of Apa Moses and other possible features like walls and tombs. For the methods used, they used the magnetic survey and ground penetrating radar and an advanced processing software for data interpretation. For the magnetic survey result, they detect here's the detected features. They detect multiple magnetic anomalies of various shapes and sizes, like squares or rectangles, and the location of depths are ranging between 0.7 to 4.8 meters. For the analysis techniques, the first one is the source parameters imaging, having depths of 0.7 to 4.8 meters. For the 3D Euler reconvolution, it is confirmed similar depth ranges. For the result, some anomalies are archaeological, while the others are non-archaeological, and these findings aligned with known excavation data in the region. For the ground penetrating radar survey result, the GPR features detected several hyperbolic reflection interpreted as buried tombs, confirmed by the magnetic data, and depths of the ground penetrating radar targets range between 0.6 to 3 meters. And here's the integrated results. And to support the reliability of this discussion, here's the reference abuse or the direct link to the research paper that served as the main focus of this presentation. That's all and thank you.